So we're going to consider the volume of the solid revolution when we take the shape or the area of y equals the square root of x, roughly looks something like that, and y equals x, roughly looks something like that. So we're going to take this shape here and spin it around the y-axis. So we're going to do this using the shell method, even though we could do this using the disk method. The issue here is how can we use the shell method to get this done. So the thing to recognize, I'll do a little erasing here, is graph again, that one cross section of our shell is going to occur somewhere here. Right, so we're going to have a cylinder whose radius is the distance from the y-axis to the shell, and this expression here is the height of the shell. So we're rotating this about the y-axis. Now, we saw that in principle what we're doing is we're integrating 2 pi r h. In this case, we'll be integrating with respect to x. Right, so this will be dx. So the question is, how can we represent all of these things? The distance from the y-axis to the edge of my shell is going to be x. So the radius of my expression is x. So I'm going to integrate 2 pi x. What is an expression for the height? Well, the height is equal to the upper curve, which in this case is the square root of x, minus the lower curve, in this case x. And we're going to integrate dx. Now my shells expand out horizontally. So everything's going to be in terms of x since we're integrating in terms of x. And this goes from 0 to 1. So those are our limits of integration for this particular problem. Now all that's left to do is simply to integrate this. This is a little bit easier if we clean this up. So I can rewrite it as, I'll take the constant out, 2 pi. I'm going to integrate that from 0 to 1. I'm going to distribute in the x to get x to the 3 halves minus x squared dx. This is equal to 2 pi times the integral of x to the 3 halves is 2/5 x to the 5 halves minus 1/3 x cubed from 0 to 1. This is equal to 2 pi times, when I substitute 1 in, I'll have 2/5 minus 1/3 minus, when I substitute 0 in, I get 0. And when we simplify this down, the final answer is 2 pi over 15 is the volume of our solid. The big principle here, in terms of applying this, is knowing that the area for any of our cylinders will be 2 pi r h. So we need a way to express r, and we need a way to express h. If we're using shells and we're rotating about the y-axis, then everything needs to be in terms of x, because our shells are organized horizontally, right? They're spreading out. So a principle in terms of using shells is everything needs to be represented in terms of the opposite variable from the axis of rotation. Right? If it was a horizontal line that was the axis of rotation, and we wanted to use shells, then everything would need to be in terms of y. In this case, our radius, the distance from our axis of rotation to wherever our shell happens to be, is a distance x, and the height of our shell, wherever it happened to be, would always be the upper curve minus the lower curve.